Last week, where we're not just looking at one graph anymore. We're looking at two graphs together, right? I don't just have one line, I have two lines. So that means I'm not just going to shade one line, I'm shading two different lines, okay? The part where the two lines overlap, that shows us where the solution is, okay? So do you see I have this like white area up here, and then there's kind of the light gray area here and a light gray area here, and then there's this dark gray area down here. You see that? Yes? The white area tells me points that are not a solution at all. These light gray areas tell me points that's a solution to one of my inequalities, but not both of them. It's only in the dark area down here where there's going to be solutions to both of the inequalities. So can you please write that down? Which points are in the solution? Which points are in the solution? A, B, C, D, E, or F? Write them down on that paper. Which points are in the solution? You can see it on your paper as well. Okay, is A a solution? No, it's only a solution to one of the inequalities, not both. What about B? No, B is no good either. What about C? What about D? Yeah, D is good. What about E? Yes. What about F? Yes. Very good. Okay, so when I have my graph completed, it's really easy to tell what the solution is or not. But we can also, right down here, is this graph shaded? No, it's not. So what else I can do is I can test points in the inequalities, okay? And that's what they did here with 0, 0. They took 0, 0. They plugged in 0 for x and 0 for y. When I plug in 0 for x and 0 for y into this first inequality up here, I get 0 plus 0 is less than 1. So 0 is less than 1. That is true. So 0, 0 is a solution for this inequality. But then when I plug in 0, 0 into the second inequality, I end up with 0 is greater than 4. That's false. So it's not a solution to this second inequality. Okay? So therefore, if it's only a solution to one, it's not a solution to the system. It has to be a solution to both. So let's do the same thing for negative 4, 3. I'm going to take negative 4 and plug it in for x, and 3 and plug it in for y. And we'll start with this top inequality. X plus y is less than 1. If I plug in negative 4 for x and 3 for y, I want to check to see, is this true or false? What's negative 4 plus 3? Is negative 1 less than 1? Good. True. That means that negative 4, 3 is a solution to the top inequality. Let's try the second inequality. Y is greater than or equal to 1/2 x plus 4. But I'm going to plug in negative 4 for x and 3 for y. So is 3 greater than or equal to 1/2 times negative 4 plus 4? I don't know off the top of my head, so let's simplify it. What's 1/2 times -4? -2. What's -2 plus 4? 2. Is 3 greater than or equal to 2? Yeah, 3 is greater than 2. That's true. So it's a solution to both inequalities. That tells me where the solution section is, right? Because I'm either going to have my solutions in here, down here, or over here. But now that I know -4, 3 is a solution, that tells me where all my solutions are. So let's plot -4, 3. -4, 3, it's right there. That tells me that this whole little slice right there, that is my solution. Do you want to see it another way?
Yeah. I just thought -4 and -3. -3.
Yeah. I am going to show you another way though anyway. So let's think about this purple inequality and the pink inequality. How can I tell which is which on my graph? Which one's going to be the solid line and which one's going to be the dotted line?
The dotted line is going to be the top one.
The dotted line is going to be the top one. Why? Good. Good. The purple line has to be this dotted one, right? And what is the inequality in that? What's the symbol say? Huh? Less than. So does less than mean I shade under or shade above? Below. So I shade below my dotted line. My pink line has to be the solid one. And that inequality says greater than, so do I shade above or below? So again, look at that. My solution is still this section right here where the purple and the pink overlap. Okay, does that make sense? I hope so. Okay, I want you to try 1.1, 1.2, and 1.3. I want you to tell me a point that is in the solution region. I want you to tell me a point that is a solution to neither of the inequalities. And I want you to tell me a point that is a solution to one of the inequalities. 3 letters, A, B, C, D, or E, or F. 1.1 and 1.3. I'm coming around and checking them.
And then start working on 2.1 to 2.4.
Yeah, it is. No, we gotta solve it. Gotta solve it. I said no. I said no. Bro, it's just gonna guess. I said no. This is actually it.
And now there's a couple things in there that she doesn't deserve. So make sure you stay on top of it. It's hard. Tuesday AM sub, does that mean you're gonna have a sub in the morning?
Yes. And then you guys will have a sub on Wednesday.
In the afternoon?
No, I'm not going to a wedding. I do have another wedding that's coming up.
Alright.
No, I have to proctor a test in the morning tomorrow. And then in the afternoon. B and B.
Wait, that looks like a D.
1 to 2.4. Okay, 1.1. What is a point in the solution region? E. What is a point that is not a solution to either inequality? D. What else? B. That's it, right? B or D. And what's a solution to just one inequality? A or F or C. Good. Okay, let's look at these ones. What time do we get done? 2:15? Okay. Just been behind all day. That's okay. All right. We're going to determine if each of these points is a solution or not. Would you rather test the points, plug in the values into the inequalities, or do you want to shade the graphs and just look at the graph? What do you think is easier? I think shading is much easier. So let's look at these two different lines. I've got this top one, we'll call it the purple line, or pick whatever color you want. And then the second one is going to be the pink one. Okay? How do I know which one is which? What do you mean? But what does that tell you? Huh? Yes? Yeah, the solid or the dashed line. So what does the purple one have to be, solid or dashed? Solid, so it's going to be this one, right? And my inequality says greater than. So do I shade below the line or above the line? Above. Oops, I didn't mean to do pink. I meant to do purple. And what about the pink one? Is it greater than or less than? Greater than, so above or below? Above. So now that we see that, we can determine whether these points are a solution or not. Is 3, 2 in the solution region? No. So only in the purple area. It's not in that overlapping area, so no. What about -1, -3? No, that's in the white part. It's not any solution at all. What about 1, 6? Yeah, that one's good because it's in this overlapping section. And what about -2, 2? No, it's in the pink area. All right. Okay, flip over to the other side, please. All right, I'm going to do one of these with you, maybe two, depending on time, and then I'm going to have you do one for practice, and that's going to be what I'm grading. Let's remind ourselves how we graph an inequality. I'm always giving you inequalities in slope-intercept form, so that's always your first step. Plot the y-intercept. And then once I plot the y-intercept, what do I do? Yeah, I use my slope to graph the next point. Use the slope. Right, and slope is rise over run. Use slope to plot other points. And then, so I have my y-intercept, I use my slope to graph my next point. What do I do from there? Yeah, but how do I know which line to draw? Look at the inequality, right? Solid, let me write that better. Solid or dashed line, right? Solid, it's going to be this or this. Dashed is going to be this or that. Solid, dashed. Okay, now I've drawn my line, so then what's the last step? Shade it. Shade above or below. Shade above if we have greater or greater than or equal to. Shade below if we have less than or less than or equal to. So let's look at this first one. So take your two colors and just assign a color to each of the lines. And let's look at this top line first. What is my y-intercept? -2. That's where I start my line at -2. What is my slope? -5. Which means -5 over 1, right? So I'm going down 5, right 1. But if I try and do that, I run out of graph. So let's go in reverse instead. We're going to go left 1, up 5. Left 1, up 5. Now, do I need a solid or a dashed line? Solid. Got my line. And then do I shade above or do I shade below? Below. It's less than, so I shade below. So that's over here. Okay. And is that it? Am I done? No, I have another line to graph. So my pink line, what's the y-intercept? 2. That's where I start. I start at 2. Whoa, whoa, whoa. What's my slope? Negative, just -1 over 1. Okay, that means I go down 1 over 1. Down 1 over 1. Do I do a dashed line or a solid? Dashed. Do I shade above or below? Why below? It's less than. So I shade under the line. Okay, so tell me, is 0, 0 a solution? No, it's not. Is 2, 2 a solution? Is 3, 4 a solution? No, it's just in the purple area. What about negative 2, negative 2? Yes. Okay? What time is it? Do you want me to do one more with you? Well, you can go ahead, Anthony, and you can keep going. Which one do you want to do, 2 or 3? Okay. Again, assign one color to each line. Look at the top line. Where's my y-intercept? Negative 1. And what is my slope? Negative 4 over 3. So I go down 4 over 3. Down 4 over 3. Before I draw my line, I think to myself, solid or dashed? Solid, because it's less than or equal to. So solid line. And then, do I shade above or do I shade below? Below, less than. Okay, am I done? No. What do I do now? Yeah, do the other one. So what's my y-intercept? 2. And what's my slope? A negative 1 over 3. That means I need to go down 1 over 3. So down 1 over 3. There you go. I got my 2 points. Dotted or solid line? Dotted. Shade above or shade below? So less than or greater than? Less than. So what does that mean? Shade below. So again, one more time. Is 0, 0 a solution? No. What about 3, 3? No. What about negative 3, 4? What about negative 2, negative 2? Okay. Can you guys try and do 2 and 4 then, please? You've got 10 minutes to do them both. 2 and 4.